Hi there. Thanks for joining us. This is the podcast known as Space Nuts. My name is Andrew Dunkley, your host. It's good to be back, and thanks to Heidi for filling in for the last few weeks. She did a fantastic job, and I'm surprised I got my job back. But anyway, that's the way it goes. Coming up, we are going to look at a massive layer of what could be diamonds inside the planet Mercury. We'll also be following up on the Lucy spacecraft, which is basically revealing a conjoined asteroid, amongst other things, probably other asteroids, and a plan to map the dark ages of the universe. We'll talk about all of that on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining us to unravel all of that is Professor Fred Watson, an astronomer at large. Hello, Fred.
How are you doing, Andrew? It's great to see you back.
Thought it was my front, but yes, I'm well.
Sorry, I misread your face for the back of your head. Sorry.
Yeah, well, kind of getting the same with the hair loss. Look, there's
Tell me about it.
I'm really well. We had a fantastic trip, and I won't bore everyone to death with all the minor details, but we flew into Miami eventually. We had a delay, so our flight, we couldn't make our flight, so we had to do an extra flight to Toronto and get a flight to Miami. So we ended up being awake for about 40 hours, I think it was, by the time we landed in Miami. And then we went, you'll love this, we went to our hotel near the port because we were getting on a ship, and there was a music festival. So guess how much sleep we got after that.
Yeah.
Got on the ship, did Colombia, did the Panama Canal. Gee, that's intriguing. That is such an amazing piece of engineering, that thing. Then we whipped around to Guatemala, Costa Rica, Mexico, got off in LA, flew to Vegas for a few days, and we went to the Sphere. Do you know about the Sphere at Las Vegas?
No, I don't think so.
It's a big ball.
Yes, it sounds like that. Yeah.
But the outside of it shows images, constant images. It's like a round television set, if you like.
Wow.
But it's a sort of an animated setup. But inside, they do concerts, and they've got the Eagles coming up at the Sphere in the next couple of months. I think it's next month. And there was a show on called Postcard from Earth. And you sit in what's a giant amphitheater, but the screen inside the Sphere is all around you, as far as you can look to the right and left, in front of you, and up over your head and behind you. And the images make it feel like you're actually, you know, the feeling when you're in a jet airliner and you're coming into land and they move and maneuver and just get into position to make the final approach. That's what it feels like. That's the way the images make you feel. You feel like you're flying in the open air in this amphitheater over the earth. The images are such super high definition, they look real. And I took a few photos while I was in there, and I looked at them later, and it looked like I was actually standing on a snow-covered mountaintop looking out over the mountains. But I was in a chair in a room. Amazing technology and really, really enjoyable. So that was probably my highlight in Vegas. Then we flew to San Francisco, and we did all the stuff you do in San Francisco, and everyone knows what that is, Pier 39 and blah, blah, blah. Did all that. But I discovered that they have driverless taxis in San Francisco. You order your ride on a map. It just on an app. It turns up in front of you. You press the unlock button on your phone. You get in. You press start. Takes you wherever you want to go. I didn't even know it was a thing yet. I thought they were testing them, but as it turns out, they are operational in 4 or 5 major cities in the United States, and they work. They work really well. And you know what? High quality vehicles, Jaguars. I was newly impressed.
Yep.
But if anyone's going to New York, I think they're in San Francisco, Portland, maybe Seattle, maybe a couple of other places. If you're going there, give it a try. It is really great fun. really great fun. So we had a ball. Saw crocodiles in Costa Rica, all sorts of stuff. It was a terrific trip. Really, really enjoyed it. So back down to Earth. Back down to Earth we are.
And now you're going out into space with the nuts.
Indeed. Yes, and our first port of call will be Mercury. Now, this story, I had a good read because, if you can get hold of some cheap diamonds, it's always a good thing. But these ones, I imagine, are hard to get to.
Yeah, that's right. It's a story that basically comes from a paper which is in Nature Communications. It's called A Diamond-Bearing Core Mantle Boundary on Mercury. That really tells the story. And its authors are at Chinese and Belgian universities or institutions. And it's essentially the story here, Andrew, is that the data we've got from Mercury is fairly sparse because there haven't been that many visits. But a spacecraft called Messenger did basically send back some extremely interesting data, which essentially showed that carbon is very abundant on Mercury. And in fact, they reckon there's a crust that is perhaps the remnants of a crust that was made entirely of graphite. And so that means that, when Mercury was being formed, its core and its magma ocean, that's the sort of ocean of molten rock that surrounds the core, which the Earth once had in its era when it had a magma ocean. They're suggesting that those regions of Mercury were saturated with carbon. And so what they've done is they've built models of the interior of Mercury with this carbon sort of thrown into the mix. And it turns out that you've got some really interesting thermodynamics and all kinds of interesting pressure temperature gradients, and maybe an influence of sulfur as well, which is also present. They basically have worked out from these models that because of the pressure bearing down on the boundary between the core of Mercury, which is probably molten metal, and the mantle, which is sort of semi-molten rock, the layer in between is carbon rich. That is their interpretation. And with these pressures and temperatures, that carbon simply turns into diamond. And so the thinking now is that there is a diamond layer at the top of Mercury's core. And they also provide evidence that suggests that it's the different sort of transmission of temperature, which we usually call conduction, of a carbon-rich mantle, that is sort of explaining some of the phenomena that we see on the surface of Mercury, the cratering, and possibly even ancient volcanic activity, which might also be giving you some evidence of this diamond layer. The chances of actually digging it up, I think, are pretty slender, because you're talking about something that's at least 500 kilometers below the surface.
I just looked it up. I just thinking if it would be remotely possible to get near it. No.
I don't think so. Mercury is interesting because, and we've talked about this before, but it's got for its diameter, which is roughly 5,000 kilometers, it's got a core which is quite large. It's roughly 4,000 kilometers. So its core is much larger compared with the diameter of Mercury than the Earth's is, which is a lot more compact. And the thinking has long been that maybe Mercury got like that because of a collision perhaps in the early solar system that knocked off most of the material of the mantle and left not quite a naked core, but a core with a fairly thin mantle over the top of it. And
so the Mercury could have been a bigger planet at some stage.
That's possible. That's right. Mm-hmm. That's the thinking. And that, one of the reasons why scientists can work on this planet with such good information in terms of plugging it into their models so that we can sort of see what's happening. One of the reasons for that is that unlike actually most of the other planets, certainly unlike Venus, or the other rocky planets, I should say, Mercury has quite a strong magnetic field, which was a big surprise when it was discovered. I think that might also have been a messenger discovery. So it's got a magnetic field, and that suggests a molten core, and the dynamics seem to suggest that that has on top of it a layer of diamond.
Wow. Now, I'm sort of getting ahead of myself here a bit, but in our next episode, we've got a question about fake news in astronomy and space science. And there's been a few stories over the years that have popped up, and we've got, the media's gone into a frenzy, and it's turned out to be wrong. This story, they're kind of hedging their bets because they're saying maybe, might be, could be. They're not saying definitely.
Well, that's right. That's very much the scientific way of doing things. It's and yes, look. This I'm looking at the actual paper that has been published. It was published on it's actually published quite a while ago. That's quite interesting. I didn't realise that. It was published last year. But the story has only really just emerged that there's diamonds there. Maybe it's because it's buried so far under the surface, nobody took any notice of it. But yeah, I'm looking at the paper, which is very much a scientific paper and has all the usual information there. This is not fake news. It is some interesting theoretical work based on our observations of the smallest planet in the solar system, which is no less interesting for that.
Yes, yeah. The more we study, the more we learn, the more we hope to find out about how we got here and why, etc. So it just adds a bit more relevance to what is a big puzzle, a big mystery of existence entirely. I mean, existence itself, I think I haven't said this for a long time, but existence itself is a mystery.
Yeah, call this existing? Well.
Oh, yeah. We're walking down the Monty Python road now.
Yeah, it was actually Eccles. That was a quote from Eccles in the Goon Show. Yeah. Gold eclipse.
Yes, that's right. Yeah. Gee, I haven't thought of them for a long time. Yes. Really interesting. And as Fred said, it's in the Nature Communications publication, or you can find it on dailygalaxy.com, the diamond layer of Mercury. This is Space Nuts with Andrew Dunkley and Fred Watson. Let's take a short break from the show to tell you about our sponsor, Insta360. Now, as you know, and particularly if you follow me on Facebook or Instagram, I love taking photos. On our recent trip, I was just in photo heaven. I always look for the perfect shot. I got it on this holiday with a whale breaching. So I love photography. So I was really excited to see that our new sponsor, Insta360, sells cameras and all the gear that goes with cameras. But it's not just cameras. I mean, this is top quality gear. And I'll tell you how to look at their equipment very, very soon. There's also a special deal for Space Nuts listeners. So get ready for that. Now, Insta360 is a leader in 360-degree action camera technology. Now, 360-degree photography, that's pretty new to me. And I'll explain more about it. Their latest 360-degree camera, the Insta360 X5, has only just been launched April 22nd, and it shoots full 360-degree videos in 8K 30 resolution. That's pretty amazing. It's mind-blowing, actually. I love the way technology is advancing and becoming available to people like us. So this new camera films in all directions at once. You don't need to aim the camera, just hit record. You can live in the moment. You can choose the angles you want in the edit system on the Insta360 mobile app. It's very easy. It's quick, and it's got AI technology, AI tools that'll just make the job so much easier and faster. and you can take, immersive point of view shots, third person shots. The X5 is just about every camera you'll ever need, all wrapped up into one beautiful little package. And the AAA chip is very efficient, and that means seriously smooth operational performance. Plus huge sensors and a dedicated low light shooting mode that'll deliver unmatched detail and quality day and night. X5 also features Insta360's toughest ever lenses, which are completely replaceable. So you can, take that risk if you really want to get this great shot, but you're worried about the camera, you can replace the bit. Now, as a part of this launch, and as Space Nuts listeners, there's a special offer for you. To get hold of the offer, which is a 114 centimetre invisible selfie stick worth about $24.99 US, with your Insta360 X5 standard package purchase, all you have to do is go to store.insta360.com and use the promo code SpaceNuts. Now, this is for the first 30 standard package purchases only by Space Nuts listeners. That's a 114 centimetre invisible selfie stick worth $24.99 US with your Insta360 X5 standard package purchase. Don't forget the URL, store.insta360.com, and the promo code is Space Nuts. Go and have a look at their website and see what they've got to offer. It's amazing gear, and we'll put more information in the show notes. That's Insta360, store.insta360.com. Now back to the show.
3, 2, 1.
Space Nuts.
Now, Fred, it sounds like you've already had a conversation about the Lucy mission. This is a spacecraft that's heading out to the Trojan asteroids to look at Asteroid, which would be a really good reason to go. And it's already revealed something unusual.
Yes, that's right. You
to qualify that, not unusual, because we've seen these before, but we've got a nice picture.
We do. We've got some stunning images from the Lucy spacecraft. They were taken at the beginning of this week, in fact. So this is hot off the press. The backstory is this spacecraft is on its way to survey the Trojan asteroids, exactly as you've said, the groups of asteroids that orbit in the same orbit as the planet Jupiter, 60 degrees ahead of Jupiter and 60 degrees behind Jupiter. They are known as the Greeks and the Trojans, and I can't remember which is which, but that's the bottom line.
That's part of it too.
But the interesting aspect of this is that they have basically had a flyby of another asteroid en route to the Trojan asteroid belt. And this is one that sits in the main asteroid belt, so it's between the orbits of Mars and Jupiter. And it's an asteroid that was not big enough for it to be really seen in any detail at all, other than just being a point of light from earthly telescopes. But we now have these absolutely stunning images of it. And it is surprisingly bigger than the engineers who were basically the mission commanders for Lucy than they thought. And so it's too big for the pictures that we've taken. It's actually very much the shape, I'd guess, of a peanut in its shell.
I'm going to say, potato, but no, you're right. It's peanut shaped.
Yeah, it's probably two separate objects that have gradually come together and merged with landslides at their middle, the place where they've joined. A very common appearance among asteroids. And yes, you might remember that object right at the edge of the solar system, which was called Ultima Thule for a while, and I've forgotten what Arakoth, that's what it's called now, Arakoth. That is also very much this sort of structure. It's got craters on it, which you expect because these things are constantly or have been bashed over cosmic times by other small objects. We think this asteroid is a piece of another asteroid that was collided by another asteroid, something like 150 million years ago. And so it's a remnant from an earlier collision. Really interesting object. I think the reason why I just wanted to mention it again, even though we sort of covered the story last week before the images were taken. In fact, that's when Heidi and I spoke about it. Yeah. The really interesting thing, and I'm sure this is what is exciting those engineers that I just mentioned and the mission scientists who are running Lucy, is that they used effectively an autonomous guidance system to point the camera at the asteroid, and that worked perfectly. And it's going to save them time when they fly by the 7 target asteroids in the Trojan belts, because it means that they don't need to take images and send them back, which takes several minutes, and then sort of point the spacecraft so that you've got the images in the center. The spacecraft will do it all by itself, and it was designed to do that. But this really confirms very nicely that sort of autonomous acquisition of these targets actually works. So as I've said, the only big surprise was that the asteroid is longer than expected. It was expected to be a bit more potato shaped, in fact, as you mentioned, but as we said, it's more like a peanut. So it didn't really fit entirely into the field of view of the camera, but we've got enough of it to be very, very impressed by what we've seen.
Somebody needs to give Lucy some basic photography lessons.
Well, yes, but you try it from deep space as several tons of millions of kilometers from Earth.
It's actually quite a stunning image that I'm looking at. That's a ace.com website.
Yeah, there's a nice... Sorry, go ahead.
No, and you can just see some really fine detail in it of the impact craters and the shape, and you can actually, I think you can even see where it probably joined up.
Yes.
That little recess or crevice or whatever you want to call it, where the two objects probably merged. That's my assumption.
I think that's right, with a bit of a ridge around it as well, which is what you'd find, I think, with the motion of material. I mean, these things are probably not terribly firmly bound together. They are that will be loose material in the neck that joins the two objects, which make up the peanut. The article that I've been looking at is on the Sky and Telescope website. I liked it very much because of the title, which is "Meet Asteroid Donald Johanson, Long and Lumpy," and that's the other nice aspect of this spacecraft and this space mission, which we did mention a week or so ago. The asteroid is named Donald Johanson, who was the person who discovered Lucy, that hominid fossil found in Ethiopia, after which the spacecraft is named. So yeah, it's a nice little link there, and we now know what Donald Johanson looks like.
Yes, he's bald, basically.
Nothing wrong with that, Andrew.
Nothing at all. It also reminds me that Scarlett Johansson, probably not related to Donald, starred in a movie called Lucy, which was based on the origin of the species through the hominid fossil. So there you are.
There you go. Very nice links.
Actually down a very deep and complicated science fiction path, that film, but I love it. I've watched it probably 5 times. Terrific film, if you ever get the chance. It's it's an absolute ripper. I really like the concept, and Morgan Freeman's in it as well. So, yeah, A-list stars for an A-grade movie. So, the Lucy spacecraft. Just one more quick question before we finish on that, which you may have already covered previously. But what do we know much about the asteroids that it's targeting? That region, the Greeks and the Greeks and the Romans, or whatever they were.
The Trojans and the Greeks.
Trojans, not the Romans.
That's right. Yeah,
Greeks and the Trojans. Yes.
Yeah, and as far as I remember, it's 6 asteroids from one group and 1 from the other. They're managing to sort of skirt around past Jupiter so they can check out whether these two groups are the same. We don't actually know much about them. We know, from spectroscopy and using infrared filters and things like that to look at these objects. We just see the light from them rather than the surfaces of them. We can tell that they're made pretty much like the rest of the asteroids in the asteroid belt, but there will be differences, and that's what I think makes this whole experiment very interesting, to find out what exactly differentiates Trojan asteroids from their neighbors in the main asteroid belt itself. And it's true as well that, their proximity to Jupiter, they're a long way behind and ahead of Jupiter in its orbit, but they're following the same path. That could have modified their surfaces to some extent, because Jupiter basks in subatomic particles because of its magnetic field. Who knows what effects they might have had? No doubt we'll find out when I think the first of the Trojan asteroids is intercepted, I believe, in 2027, if I remember.
Yes, it's been a long trip, this one. But it always is when you go out there.
Yeah, that's right. It is.
All right. You can read up on that one at space.com. This is Space Nuts with Andrew and Fred. Now, a word from our sponsor, NordVPN. And I've spoken to you many times about Nord products and the benefits of a virtual private network. And Judy and I were overseas recently, as you know, in South America and the United States, and I was using a lot of data to get around. But, of course, we had to do money transfers and things like that from time to time because, it turned out to be a rather expensive trip with the collapse of the Australian dollar. But to do that, I used a virtual private network to screen what I was doing, and I used NordVPN. And, of course, as a Space Nuts listener, you get an exclusive deal with them as a Space Nuts listener, including that 30-day money-back guarantee. Just go to their URL, nordvpn.com/spacenuts, and click on Get the Deal to find out all about it. Don't forget they're offering an extra 4 months if you sign up. And there are various deals. There's 2-year plans, 1-year plans, or you can pay month by month. But obviously, the longer you sign up, the cheaper it gets. And the basic plan translates to about $4.23 a month Australian on a 2-year plan. That's a saving of 74% on the basic package. If you go with their plus package, it's about $5.49 a month Australian. And these all include the extra 4 months. If you get the complete package, it's less than $7 a month, and you get all the extra bits and bobs with it in those last 2 packages, including a terabyte of cloud storage, the password manager, which I just absolutely adore. I've told you many times. There's a breach scanner as well, which works brilliantly, the ad and tracker blocker, the anti-malware and browsing protection, and, of course, your virtual private network, which is the most secure in the industry. So how do you get it? Well, you just go to that URL, nordvpn.com/spacenuts, click on Get the Deal, and go from there. Decide what works best for you. You might just want a VPN service. You can do that. Or you can add on a few other things as you see fit. That's nordvpn.com/spacenuts. And don't forget the keyword Space Nuts when you go to the checkout. So check it out today at nordvpn.com/spacenuts. Now, back to the show.
0G, and I feel fine.
Space Nuts.
Our final story today is looking at the Dark Ages. And we're not talking about Knights of the Round Table or anything like that. We are talking about the Dark Ages of the universe when we hadn't even formed any stars as yet. I'm just trying to figure out, Fred, because this mission, as far as I read, was about mapping the dark universe. But if you didn't have any stars, you wouldn't be able to see anything to map.
There you go. And that's a good point, because what, it's still one of the holy grails of astronomy is looking for the first stars that switched on. So what's sometimes called cosmic dawn, and that, exactly as you've said, that came immediately after the Dark Ages. And so the first stars to switch on are very much the province of big telescopes like the James Webb, although that probably is not quite powerful enough to penetrate back to when those first stars switched on, maybe 200 or 300 million years after the Big Bang itself. It looks back to very much that sort of era, but we're still seeing galaxies at that time when they're looking about 300 million years after the Big Bang. So we don't yet have the visible light telescopes to do that. We will have when the European ELT, the Extremely Large Telescope, comes on stream in 2028. Then we'll have a mirror big enough to probably detect the very first stars. It's 39 meters in diameter. It's going to detect very faint light indeed. So that will be, the time when we do see the first stars. But we can infer when those stars switched on by looking at the effect they had on their environment, because the first stars actually basically radiated lots of ultraviolet radiation, and that affected the cold hydrogen gas, which was basically what the universe was made of then. In the Dark Ages, the universe was cold hydrogen. That was all that there was around. And so the first star switching on basically changed the state of that cold hydrogen. And it's that these mini telescopes will be looking for. Because if you can do this for the whole sky, if you can look for that cold hydrogen signal from the whole sky, then you don't actually need a giant telescope. There's one in Western Australia. It's the size of a dining table, and it's called Edges. And a few years ago, they thought they had seen this signal of the first stars. It turned out not to be the case. It turned out to be a false alarm. But you can tell that something the size of a dining table, that's a radio telescope, believe it or not, is not, it doesn't compare with something like the Parkes dish, for example, not very far from where you are now.
Yeah.
So you can do this as long as you've got, with a small radio telescope, as long as you've got complete radio silence around you, because the signal you're looking for is right in the middle of the FM band of broadcasts. And of course, in most of the world, you're swamped by these FM radio signals. And if you're trying to find a weak signal from the universe in amongst that, you're in big trouble. And so the proposal with this, and to cut to the chase of this story, is to mount a fleet of mini satellites, probably CubeSats, and then basically put them in orbit around the moon so that they will be, for part of the time, they will be within the moon's shadow from the radio contamination that would come from Earth. Yeah. So the dark side of the moon is a very, very radio quiet place. And that's what this study is all about. Actually capitalizing on that, exploiting that to find a very weak radio signal.
Well, it makes sense. I mean, if you're going through the middle of the FM band, you're going to get all sorts of weird, wonderful buffheads. I used to be one of them.
Yes.
Yep. Yeah. Yep. No, I love them. But it's that's the dark side of the moon has some uses, and then we've got I think we've got spacecraft that have landed there recently, and they're trying to figure it all out. It's like, I find the moon fascinating in that regard because it's got so many. There's so much difference between what we can see and what we can't. Even in the terrain, it's a very unusual astral body, isn't it?
It is, that's right. And the more we find out about it, the more unusual it appears. And you're quite right. It's the, is it Chang'e 4? It's one of the Chang'e series of Chinese spacecraft, which is on the far side of the moon. And actually, that communicates with Earth via a sort of relay station, which is also on the far side of the moon. So there is at least one source of contaminating radiation for any radio telescope you put up there, but at least that can be switched off.
Yeah, well, if they choose to do so. Yes, indeed. All right. That story you can read up at dailygalaxy.com, but you can also follow it on several news outlets. Yes, hopefully they'll come up with some fascinating information eventually. I think they're still, at least, I think they're in the planning phase, aren't they? Or are they further?
It is a proposal still. That's right.
Yes. So fingers crossed they can find the money to send those CubeSats up and get that show on the road. Speaking of which, this show is ending its journey in this particular episode. Thank you, Fred, as always.
Thanks very much, Andrew. Great to see you back. And we enjoyed having Heidi very much. But it's good to welcome you back after her sojourn here.
Thank you, Fred. I appreciate that. And thanks to Hugh in the studio for not talking to me for the last 4 or 5 weeks. That was good. No, he's good. He's cool. I'm going to go to hell for that one anyway. And don't forget to follow us online through our website or our social media platforms. Always good to get your feedback, so keep that coming. And we will see you real soon on the very next episode of Space Nuts. Until then, bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.